Physics Part 422, Section Summary. Ultrasound may be generated and detected by piezoelectric crystals. Ultrasound images are formed as a result of the detection and processing of ultrasound pulses that have been reflected from tissue boundaries. The acoustic impedance Z of a medium is Pc. The intensity reflection coefficient is Z2 minus Z1 whole square divided by Z2 plus Z1 whole square. Two-dimensional scans may be obtained using a generator detector consisting of many separate crystals, all at different angles of orientation. We've got section questions. Explain why, when obtaining an ultrasound scan, A. Ultrasound is pulsed and is not continuous. B. The reflected signal received from deeper in the body is amplified more than that received from near the skin. Number 2. The specific impedance of fat, muscles, bone are 1.4 into 10 power raised to 6 kilogram minus 2 S minus 1 1.6 into 10 power raised to 6 kilogram meter per second and 6.5 into 10 power raised to 6 kilogram meter per second respectively. The linear absorption coefficient in fat and in muscles are 0.24 centimeter and 0.23 centimeter respectively. A parallel beam of the ultrasound of intensity I is incident on the layer of the fat discussed quantitatively. In terms of eye reflection, the transmission of the beam of the ultrasound as it passes through the layer of the fat of thickness 4.0 mm into the muscle of thickness 43.5 mm and finally into the bone. The use of nuclear magnetic resonance. It's our third section of chapter 15, nuclear physics. 15.3, chapter number 15, section number 3, the use of nuclear magnetic resonance imaging, NMR. At the end of this section, you should be able to explain the main principles behind the use of magnetic resonance to obtain diagnostic information about internal structures. You should be able to show an understanding of the function of the non-uniform magnetic field superimposed on large constant field in diagnosis using magnetic resonance. Nuclear magnetic resonance. Many atomic nuclei have a property that is known as spin. The spin causes the nuclei to behave as if they were small magnets. Such nuclei have an odd number of porous, Such nuclei have an odd number of protons and neutrons. Examples of these nuclei are hydrogen, carbon, and phosphorus. When a magnetic field is applied to these nuclei, they tend to line up along the direction of the magnetic field due to their spin. The motion can be modeled as the motion of a top spinning about the direction of the gravitational field. This rotation is known as precession. The spinning about the direction of the magnetic field has a frequency known as a frequency of precession or Lomer frequency. The frequency depends on the nature of the nucleus and the strength of the magnetic field. If a pulse of the electromagnetic radiation of the same frequency as the Lomer frequency is incident on the processing nuclei, the nuclei will resonate, absorbing energy.